So far we've went over parts assemblies and importing parts from outside vendors, but today we're going to be getting into the actual FTC stuff, which is creating your first drivetrain. So this drivetrain we're going to be making is going to be custom. I like to do custom because I have access to a CNC, but I'm going to be making a tutorial after this one, which goes over creating a drivetrain with Go Builder parts. But for this one, we're going to be creating a custom drivetrain that is a parallel plate drivetrain, which means on either side of the wheel we have two plates that, as the name implies, are parallel, and it's going to have mecanum wheels, and we're going to countersink the motors, which means the motors are synced as far as possible we can into the outer rims of the robot, which gives us a lot of space in the center to place our geometry. So, gonna open up SolidWorks, File, New, Part. We're gonna create the plate, the drive plate, which I talked about before, parallel plate drivetrain. We're gonna create the one that goes on the outside. Uh, I didn't cover this in the first tutorial, but if you want to set it to specific like alignments, you can hold down Control and hit space. And as you can see, we have this thing that pops up. So if we want to center it, or not center, if we want it to be completely parallel to the front plane, we can select this face and there. I'm going to use corner rectangle. I use corner rectangle the most. I know there's some people who like center rectangle, um, and it won't really make that much of a difference if you also use center rectangle, but if you want to be safe, use corner rectangle like I am. So I'm going to sketch this rectangle, and then we're going to apply our dimensions. So we're going to set this to 17 inches, and then the height to 80 millimeters. Now I know what you're thinking. I'm using IPS for the length and metric system for the tall. Or for the height? What's that about? I do that because it gives me some peace of mind because the FTC size constraints are in IPS. So whenever I have to be like mindful of whether I'm going out of bounds or not, so the drive plate is pretty much the longest part you'll probably have on your robot, unless you have like a virtual 4-bar or something. I don't know. And so width wise, I want to make absolutely sure that I have enough space on either side to fit in the size constraints. But everywhere else, I tend to use metric, unless I contradict myself in later tutorials. I don't know. But we set this to 80 millimeters because the mecanum wheels we're using are the Go Builder ones, which are 100 millimeters. So that gives us a good 10 millimeters on the top and the bottom of the parallel plate. Okay, so now that we have this, we're going to go to features, we're going to extrude this. I use 1/8 inch aluminum, so we're going to set this to 1 divided by 8, or oops, not 1 divided by 9, 1 divided by 8, which should be 0.125 inches. And once we have that, we're going to click check mark. Now that we have our basic rectangle, we're going to create some construction lines so that we can line up our mecanum wheel holes perfectly. We're going to click on line in this little sketch area. We're going to click on our face, which is going to be the front of the parallel plate. And then we're going to line this up with this side right here until we lock onto the center point. And then now, once we move the cursor around, you can see it locks onto this horizontal dashed line right here, which just makes sure our line right here is a horizontal. So we're just gonna leave it off right here. And then as you can see, as soon as you left click again, another line stems off. So we're just gonna hit escape, and then that's gone. So now we're gonna get another line. We're going to left click on this center point. We're going to go over here, and then we're going to left click again, escape. So now I'm gonna just set these two to equal by left clicking this, holding on control, and then left clicking the other one. Then we're gonna click equal right here, and then now these measurements are equal. And now we're gonna create some dimensions for this. So the mechanism wheels have a 50 millimeter radius, so we're gonna just position these maybe 60 millimeters into the drivetrain. Into the drive plate. Okay, so now we have these. We might change this later, by the way. Now we're going to create our holes. This is going to be a dead axle drivetrain, which means instead of having bearings and then a shaft going through it, we're going to have a fixed 12 millimeter Rex shaft from GoBuilder screwed into our drive plate, and then our mecanum wheel will have bearings inside it, and then a pulley screwed onto it. And then so our shaft isn't actually moving, but our wheel is orbiting around this shaft. So instead of creating like a 14 millimeter bore for the bearing to go in, we're going to create a 4 millimeter bore for the screw to go into the 12 millimeter Rex shaft. So we're going to type in 2 mm, and there we have our hole. We're going to do the same for this side, 2 millimeters, there. And by the way, when you create your circles, you're going to go in here, and then when you hover your cursor around, it's going to lock onto the center wherever your line is. So that'll automatically center for you. Now we're going to go to features and then extruded cut. We're going to click on these circles. Yeah, you might want to zoom in further. I don't know why I did that from so far away. It's always a good idea to zoom in when you're CADing because that just gives you a lot more precision. But yeah, so as you can see, this is already set to 1/8 of an inch, so we'll go through that throughout the entirety of the drive plate. So now all we need to do is click check mark. There, we have our holes. So now we're just going to do some stuff to make the design of it a little bit nicer. We're going to slap a chamfer on the bottom left and right corners. So we're going to zoom in, find this edge, click it, zoom in, find the other edge, and click that. I like to set my chamfers to 45 degrees, but you can play around with that. I'm going to set this to 0.25. Nah, that's a little too small. We're just going to do some trial and error here. Yeah, I think that looks good. We'll do a 1-inch chamfer, 45 degrees. I'm going to click check mark, and there we have our chamfer right here. And then now we're going to fillet these edges just to make sure we don't have too sharp an edge. And also CNC routers, or at least the one I have, it will only work if you have a minimum 0.125 radius of your fillets. So we're going to set this to maybe 0.3. Yeah, 0.3 looks good. We're going to select the other ones. As you can see, this tutorial is kind of like more off the cuff than the other ones. Bear with me here. Okay, so we have these, and then now we are going to slap some fillets on these. Oh, oops. Okay, so I selected the wrong face. Now there's two ways we can deselect this. We can just click on the face again and it's deselected, or we can go over here, right click, clear selections. So we're going to click on the edge we actually wanted to select. And then maybe we'll set this, yeah, we'll keep it at 0.3. Yeah, so we have our basic drive plate design. Now we're going to actually create a clone of this, or not exactly like copying and pasting, because that kind of comes up with issues because when you make a change, it doesn't really show up as well when you like Control-C, Control-V. We're going to just create an exact replica of what we just did, and this is going to serve as the inner plate of our parallel plate drivetrain. This is because there's some differences between the inner and the outer plates, and you don't want to stick with the same plate for both sides, otherwise we're going to have some issues here. So we're going to do exactly the same thing. Sketch this out. I'm going to do this a lot faster because I already showed you guys how to do it before. 80 millimeters. Extrude boss. 1/8 of an inch. No, we're going to go to line. Find the center. Go outwards. Escape. Find the center. Outwards. Escape. And then we're going to set these equal. Smart dimension. What was it? 60 millimeters? I think so. No, not 600 millimeters. 60 millimeters. Okay. So now we're going to create a little circles. 4 millimeter diameter, 2 millimeter radius. Extruded cut. Down here. Select your circles. Oops, didn't select this properly. Check. Okay, we have our circles. Gonna do some chamfering and filleting. Bam. Bam. Fillet. I should be zooming in. Yep, it's already set to 0.3. Check mark. Okay, so now we have our inner and outer drive plate. We're going to Control S this, save it. We're going to call it inner drive plate. Oops, plate. Why am I so bad at typing? Okay, we're going to create a new folder, or at least I'm going to create a new folder, call it Drivetrain tutorial, just so I can keep everything organized for myself. Part folder, assembly folder. Okay. We go to part, save this, exit out of this, go to our other part. We're going to call this outer drive plate. Okay, so now we have our drive plates. We are going to now create a new assembly. So now we're going to start working on our chassis, which is basically just the drivetrain but without the wheels. We're going to, as you can see, it shows like the parts we just last used. I don't know why it doesn't show the inner drive plate, but it does show the outer drive plate, so I'm just going to drag this in here. We're going to go to assembly, insert components, browse, and then we're going to get our inner drive plate. Okay, so now I want to line these up perfectly. So what we're going to do is we're going to concentric mate these holes that we created for our mecanum wheels. So I'm going to select that, left click this while holding control, let go of control, click concentric mate. Now we're going to select this again, select the other side. Oh, I don't know why. Yeah, sometimes when you let go control, maybe if you let go of it too fast, it will just like not show up. So usually I just go to the mate menu and then fix that. We're gonna do concentric. Okay, so now that we have our parallel plates lined up, we're going to get the Rex shaft from GoBuilder's website. In this case, we're gonna use a 72mm one because I think that's the thinnest we're gonna be able to get for this drivetrain. We're gonna go to their website, click on structure, click on shafting and tubing, and then we're going to go to aluminum Rex shafting. And then we have a list of different measurements. We're going to select 72mm. As you can see here, it's basically just a Rex shaft or a hex shaft, except it has a threaded hole, so we can insert screws into it and lock it into our drive plate. So we're going to click the step file, open up the zip file, open up the step. We're just going to wait for this to come into our Solidworks. So it's reading and loading the model. We're going to get the import diagnostics. Sure. If you don't want to do it, you can just click no. It will be a lot faster. I don't think there's never really any faulty faces or anything. Especially on these Rex shafts with these threads, it's really intensive on SolidWorks' like software or your CPU. So it's gonna take some time if you have a computer as bad as mine. So we're gonna hold down Control and S. We're gonna call this 12mm aluminum. I don't know why I say aluminum right like that. Aluminum. Okay. Rex shaft. 72mm. You can name it something else, but just make sure it properly describes what the part is. SolidWorks tutorials, drivetrain, part, save. Cool. So we've imported this part. We're going to go back to our assembly. We're going to go to the assembly tab and then insert components, browse, and I'm just going to expand this right like here, so it's a lot easier to pick what parts you want because you can just see a graphic of what they are. I'm going to double click on this, set this down, and now we're going to click on the edge of this hole and then this hole right here, control click it, and then we're going to concentric mate this. Okay, so now this is, you can see this is lined up with the hole right here, but it's still free moving. So what we're going to do is we're going to click this, and then click this plane, and then coincident mate it. And then we're going to do the same thing for this other side. Click that, hold down Control, click this, coincident mate. There. And then we're going to do this again. Instead of importing again, I'm just going to select, go to the feature tree, and select the part. If you try selecting the part in like that open area like this, it's going to come up with errors. So just go to the feature tree, select the part, Control and C, Control and V. So yeah, we've pasted this in. We're going to select this hole, go up here, hold down Control, click this other circle, click concentric, and then we're going to pull this out, click this face, click the other face, coincident made it. Basically just the exact same thing we did here. Okay, so now we have something going. It's kind of starting to look like a drive module at this point. So now we're going to import our wheels. So we're going to go to GoBuilder's website. I'm just going back to the home page every time for the sake of clarity. If you know where everything is, you can just skip past like me looking for this for wherever the part is. So we're going to go to Motion, Wheels and Tires, Mecanum wheels. Oh, they're still out of stock. I need to buy these. Okay, click on the step file. Same thing as last time. Oh well, actually, we have for the mecanum wheels, since we have a left slant mecanum wheel and a right slant mecanum wheel, we'll have two different zip files. So you're just going to go into this zip file and then open this up, and then you're going to go out of it, and then open the other zip file up. It's a little more complicated, I guess, but if you've ever used Windows before, you know how to do it. Journal file cannot be created. Okay. And as you can see, these parts are all grayed out. They don't really have any color to them or texture. But later in the series, I'll show you guys how to add colors and textures to it so that when we start doing renders and stuff, your assemblies and parts will look really nice. Okay, so we're going to save this. At this point, you should know how to save stuff, I assume. I believe this is the left slant mechanism. Let me check the diagram first just to make sure. Yep. Oh no, this is the right slant. Okay. So this is the right slant mecanum. We'll call it right slant mecanum exactly what it is. Can't mess it up. Solidworks tutorials, drivetrain, part, or no. We're going to go to assembly because it's an assembly file. I have to separate the assemblies from the parts. But if you want to change it, that's your personal preference. We're going to exit out of this. We're going to go to our other mechanism. Oops. Okay, we're going to go to our other mechanism, saved as left slant mechanism. Documents, noise, design, Solidworks tutorials, drivetrain, assembly. There. Okay. Oh, Solidworks is crashing. Okay, we're good. Alright. So we're going to. So we have our drive pod right here, but what we're going to do now is we're going to create something I call a mecanum assembly, which is an assembly which contains three components: your mecanum wheel, your pulley, which is used to drive the mecanum wheel, and bearings, which are used to mount the mecanum wheel onto the shaft. So we're going to import yet another part and go back to the home page. Make sure it's all clean, you guys can understand. Motion, bearings. We're going to go to flange bearings, 12mm ID, 32mm OD, 10mm thickness. This is the one you're going to select. As you can see, it's a pretty big bearing. I'm going to click step file. You can also use the bearings from Robotics. They're a lot smaller, but I just use these ones because they're more compatible with the GoBuilder wheels. But if you want to switch them out for Robotics ones, you're gonna have to create. You're gonna do the same thing, but you're gonna have to create like a little part that will hold the bearing on the other side where it connects to the face. But I just like to use the GoBuilder bearings because it's a lot more streamlined. And exit out of this. I'm gonna stop doing import diagnostics because I think it's crashing my computer. Okay, 12 millimeter ID bearing. Sure. Bearing. There we go. Documents. Atlantis. Design. Solidworks tutorials. Parts. Oh no. Drivetrain tutorial. Parts. Okay, now that we have our bearing, we're going to create our pulley. I linked a video in the description on how to create pulleys. You can also use go-go pulleys, but for this drivetrain, we're going to use custom pulleys because they're a lot more customizable. You can customize the tooth counts, the HTD, and the width of the pulleys, which is a lot better, and I just like to use them a lot more. But yeah, video linked in the description. It's a very, very good video from the Antidote 14320. It will show you exactly what to do to create your parametric pulley. But I'm just gonna run through it over here really fast to just to be safe. So I'm going to open up the OpenSCAD program. Again, if things don't make sense right now, go watch the other video and set everything up. We're going to click on the pulley file that we downloaded. Okay, so now we're going to set this tooth count to let's go 40 teeth. We're gonna so the gear ratio for this drivetrain is going to be 16.1 to 1. I think that 20 to 1 is a good ratio, but for this year, I think we're going like a bit faster, so 16 to 1. Yeah, so we're going to set this to 40 teeth, and then we'll make another pulley that's 34 teeth. So when you belt a smaller pulley, which is 34 teeth, to a larger pulley, which is 40 teeth, that'll reduce the gear ratio because we have a 13.71 motor that we're going to be using, but I think 13.71 is like way too fast of a thing, of a ratio. So we're going to just gear this up to a ratio that's much easier to manage. Shaft diameter just tells you how large the hole in the center will be. We're just going to set the shaft diameter inside Solidworks, so we're just going to set this to 0. The profile, I use HTD 5mm belts, so we're going to set this to 10. So now we're going to click F6. It's going to be loading. See this green bar down here. Okay, so now we have our pulley DXF. This is basic. We're basically just gonna take this and convert it into a sketch. So we have this right here. We're gonna click on File, Export, and export as DXF. We're gonna call this 40T pulley SCAD. So now we're gonna go to Documents, Atlantis, Design. Solidworks tutorials, Drivetrain. We're actually going to create a new folder right here called DXF to hold all of these files. DXF. Yeah. Okay, so now we're going to create our smaller pulley. We're going to set this to 34 teeth. Going to click F6 again. Okay. So now we have it loaded up right here. Going to click File, Export as DXF. 34 T pulley SCAD. Okay, so now we have our SCADs. I'm going to discard this. Now we're going to go to File, Open. We'll do the 40T pulley first. DXF. Then we're going to select our 40T pulley sketch. We're going to click Import a new part as 2D sketch. Next. We're going to take this drop down and then select millimeters. Then we're going to click Finish. Okay, so as you can see, it's basically a sketch except it's kind of hollow, but it still works as a sketch. We're going to click Extruded Boss/Base. And then I'm going to set this to 9.8 millimeters because that complies with the go-go build width. I believe the width of go-go boats are 9 millimeters, so 9.8 millimeters gives you a solid 0.4 millimeters of clearance on each side, which gives you a bit of flexibility. You're going to click check mark. We're going to go to sketch, circle. We're going to create like some bounds around it just so the belt doesn't fall off the pulley. We're going to set this to, let's go 34 millimeters, sure. So 34 millimeters in radius. I'm going to click extruded boss base, 1 millimeter, oh it was not a meter, 1 millimeter. Click check mark, there, we have our bound. And we're going to click sketch again, circle, select your face, align at the center, make sure you're lining at the center so it's not offset. And open it up, 34 millimeters, features, extruded boss face, check mark. Okay, so now we're just going to slap some chamfers and fillets on it. I believe my computer's lagging a bit because like I have the recording window open. Okay, so 1 inch is obviously way too big of a chamfer for this, so we're going to set this to 0.5 millimeters. And the outside, I'm going to set it to 0.25 millimeters. Okay, almost done. We just have to create our bore. Gonna create a circle sketch at the center of the pulley. So this sketch, the circle sketch, we're going to make it 16 millimeters, and that's the size of it. That's the outer dimension of the bearing. We're gonna go all the way through. We can select this drop down thing, or we can select through all. That'll just automatically go through all of the entire bearing. Yeah, so now we can create a countersink by loading this up, and then I'm going to do 20 millimeters. Then we're going to do extruded cut, 1 millimeter. What this countersink is it sinks the flange of the bearing into the pulley, so that gives you a little bit of space. And check mark, and there, we have our pulley, or at least the big one. So we're going to say 40T pulley, traction tutorial, part, save. Okay, so we have this. Yeah. So now that we finally have all of our components, we're going to create a mecanum assembly. I'm going to click New Assembly. We're going to click Browse. We're going to get our bearing. Oh no. We're going to go to Assembly. We're going to get our left slant mecanum. So we have our mecanum wheel. Now we're going to go to Insert Components, Browse, and find our 40 teeth pulley. I'm going to drop this down. And now what we're going to do is we're going to lick this mecanum wheel, and we see that there are these lock nuts right here, which make it impossible to fit this pulley flush onto the mecanum wheel, which is bad. That's not good, because we want everything to be as slim as possible. So what we're going to do is we're going to create cutouts in this pulley where the lock nuts will be able to stay, so they won't inhibit the size of our mecanum assembly. So we're going to click this face right here, the one without the countersink, and then we're going to select the mecanum plate, release control, coincident mate. We're going to concentric mate these together. Okay, so we have our pulley on right here. What we're going to do now is we're going to right click, and then we're going to select this little icon right here that says edit part. It's going to ask you to save it, so we're going to call it left mecanum assembly. Make sure you name it left mecanum assembly if you chose the left slant mecanum, and the right mecanum assembly if you chose the right slant mecanum. So we're going to go to assembly, save it right here. Okay, so here's how we're going to make these holes. We're going to right click this pulley and select this icon right here that says edit part. Now we're going to swivel to the back of the assembly, click sketch, circle, we're going to create a circle, and then we're going to select the plane of the inside plane of the pulley. So I usually just get it through this hole right here, but wherever you're able to find it, sure. Now we're going to see the screw right here. This is the screw that goes into the lock nut, so this is our target. when we hover over the screw, as you can see, it turns orange, and then we have a little crosshair right here. You're gonna align your pencil with the crosshair, and you can see a little coincident icon next to your pencil, that yellow icon right there. You're gonna create a circle there. It's lagging a bit, and you can see that it's automatically aligned perfectly to that lock nut. Now we're gonna click. We're gonna type in 4.5 millimeters. Now we're going to do the same for the 3 other holes. So you're just going to find that crosshair, click it, okay, there, 4.5 millimeters, go over here, 4.5 millimeters, here, 4.5 millimeters. Okay, so we have our holes. But now we're going to click on the center of the holes, or wait. Okay, click on the center of the holes. Now we're going to go over to this tab that says Existing Relations. We're going to right-click, delete all, and then select Fix. What this does is it removes the relation of like the coincident to wherever the lock nut is that's just going to make problems for you later if you ever try to switch things up. We're just going to fix this in place so that usually in assemblies you wouldn't because you're actually building a robot, but these are just sketches, so it's okay. So we're going to click this center point, do the same. Oops, didn't delete it. Okay, fix, click this, delete all, fix, oops. Okay, click this, right click, delete all, fix. Okay, now we're gonna click exit sketch, and then extruded cut, and make sure those that sketch was selected so that it automatically selects these 4 holes. We're going to do through all. I'm going to click check mark. And there, we have our holes right here. As you can see, we've created some nice little holes for our lock nut to be in, so now we're not going to have any problems. Cool. What you can also do is, as you can see, it's actually going into this flange. So what I'm actually going to do is I'm going to right-click this extruded cut, and you can see Edit Feature. Oh, oops, selected the wrong thing. We're going to right-click Extruded Cut and click Edit Feature. And then instead of selecting through all, you can do blind, and then maybe do 4.5 millimeters, so it goes like pretty much halfway through. Or you can go for maybe 7 millimeters. That's probably the better option. So we're going to do 7 millimeters. We're going to hit check mark. So now we still have that pocket for the lock nut to be in, but you can't really see it, 1, and 2, it doesn't interfere with the flange. So I kind of messed up by going through all, but I was able to teach you guys how to edit extruded cut features, so it's alright. Alright, so we have our pocket, and we can now we can rotate this pulley right here. But we're gonna actually lock this onto the mecanum. So we're gonna select this face again, and then we're just gonna turn it until we see these pockets we created before. So we're gonna select the inside rim. I know this can get a bit hard, but just be patient. Yeah. So we'll find this hole right here. We'll select it, and then click on the outer rim of the screw, and then concentric these together. So this just automatically lines up the hole we created with the lock nut. So now we're good, and we can't rotate this pulley. Okay, so now we have to create 4 more holes so that we can use to mount the pulley onto the mechanism. So we're going to click on this outer face, right click, and then edit part. Going to just click the circle, get that over there, and then line this up. And now we're going to create 2 millimeter holes. Well, 4 millimeter holes technically, but 2 millimeters in radius. And plus Solidworks accepts radius and not diameter. So make sure you're entering 2 millimeters and not 4 millimeters. This is final one. Yeah, once again, make sure you're perfectly aligned with this hole. 2 millimeters, okay, there. So now we're going to click Exit Sketch, Features, Extruded Cut, and this one we're going to go through all. There we go. So now we have holes to mount our to mount our screws. To mount our pulley onto our mechanism. So yeah, so finally we have this mechanism wheel assembly done. We're gonna have to create a second mechanism assembly later for the other wheel, but for now we'll just save this, just so you guys don't get fatigued with just creating the same thing over and over again. I'm gonna save this, I'm gonna exit out of this tab. Okay, so now we're going to click Insert Component, Browse, Left Mechanism Assembly. It's going to prompt you to rebuild, click Rebuild, and then plop this down right here. Oh, I forgot. Oh, wait. Sorry, we're not completely done with the mechanism assembly yet. We're going to go back to this. We're going to open. So, what you can do in SolidWorks is once you close the tab, you can actually open whatever your file you're looking at inside an assembly. So, say I wanted to open this mechanism assembly, we can click on this left mechanism assembly in the feature tree, right-click it, and then click on this open icon that says open subassembly. And there we go. So before we're completely done, we're going to put our bearings on. We're going to concentric mate these together. By this point, I expect you guys to know how to mate. So I'm going to start rushing through the mating processes, unless a new mate comes up that we need to use. Now we're going to coincident mate this flange in. And as you can see, this counterbore, or this countersink we made, is not only not like deep enough, but it's also like way bigger than it needs to be. So we're actually going to edit this counterbore. And the reason we're doing this is so that you guys can get used to editing things you've already made. Okay, so we're gonna drag this, and then we can actually select this rim right here. Make sure you're not selecting this rim, this inside rim. Select the outer rim, and then we can select cordial. I don't know how to pronounce that, but cordial, and that basically just sets it equal to whatever your locks a circle onto the other circle perfectly. I can't really explain it that well, but there's my explanation. Okay, I'm gonna exit the sketch, and now we fixed the problem where the bore is too large. So now that we've fixed the size issue of the circle, we're going to fix the depth issue. So for good measure, we're just going to delete the coincident mate that we made earlier that mates the bearing to the pulley. And how we do this is we're going to open up the bearing file, and then you can see there's something that's called mates and left mechanism assembly. There's a folder there. That's where in this folder it shows all the mates concerning that specific part. So we're going to click on our coincident mate here, and then there's two things you can do. You can either right click it, oh I don't know why it's glitching out, and then click delete, or you can just click the delete key on your keyboard, which is what I do because it's a lot faster. I'll drag this back here. Okay, so now we can see this is free to orbit again. Yeah, so now this is a feature we haven't used yet. We're going to click on this evaluate tab and click measure. And this is exactly what you think it is. It's basically just a virtual tape measure. I'm going to select this face and select this face. And then over here there's a little green line and it says 2.5 millimeters. Great. So now we're going to edit this counter bore to be 2.5 millimeters in depth. Oh wait, no. Sorry, that was the wrong one. We're going to right click the correct, cut extrude. Edit this part out. Okay, so now we're going to edit the cut extrude so that it's exactly 2.5 millimeters. So we're going to just click on this face right here. Okay, we're going to click on this cut extrude, right click it, and then edit feature. And then we're going to enter 2.5 millimeters. There we go. So now we're going to redo this mate. Select this. Select the other one. Coincident. There we go. It's nice and flush. Now we're going to copy this, paste it, and we're going to do yet another thing we haven't done yet. We're going to reverse a mate alignment. So we're going to take this face and coincident mate, but oh no, this bearing is not like aligned properly. The outside of the bearing is facing that way. We want the outside of the bearing to face inside the mechanism. So we're going to open this up, go back to the this mate and left mechanism assembly folder, click on this coincident mate, right click it, and then you'll see an option called flip mate alignment. There we go. And yeah, so as you can see, this is fixed so that the majority of the bearing is facing inside, which is great. Now we're going to concentric mate this, and now we're actually done. Okay, there we go. So we're done with this left mechanism assembly. I'm going to leave this tutorial off here, and then we're going to pick it up in the next tutorial. So yeah.